Yeah, we'll probably need it. All right, here we are. So we've got 20 questions that we worked on, and we'll just go ahead and review them real quick. And then, of course, depending on how the pictures turned out on the copies that I made for you guys, it was a little hard to tell what was actually in some of the pictures, so I put the concentrations up there for you guys. So I've just got a copy myself. Let's go ahead and go through this. So it says you're responding, proper dose of etomidate, your partner who wants to do RSI. So patient weighs 175 pounds. So first of all, we need to pull the relevant information from the question, right? So this patient weighs 175 pounds. All right, and you're to draw up 0.3 milligrams per kilogram of etomidate. And it asks you how many milliliters will you have to draw up? Okay, that's the first part of the question. So what we need to do is we need to look at the vial, and it says 2 milligrams per milliliter. You guys are good with that? So the vials have 2 milligrams per milliliter. And how many total milligrams are in the vial? 20. Okay. So 2 milligrams per milliliter, there's a total of 20 milligrams in the vial. So how many milliliters am I going to have in that vial? If the concentration of the vial is 2 milligrams for every milliliter, and there are 20 total milligrams, what do we got going on there? 10 milliliters, right? I have a total of 10 milliliters in that vial. Okay. All right, because 10 milliliters is going to equal how many milligrams? 20. And if you want another way of figuring that out, all we have to do is set up that dimensional analysis that we talked about in pharmacology. And so what do I know for a fact that I have? You remember how we set that up. So what do I know? I know for a fact I've got 2 milligrams per 1 milliliter concentration. So I can do 2 milligrams in 1 milliliter. And everyone would agree that we know that for a fact because it tells us that. And then I want to know, well, I've got 20 milligrams. So I'll put 20 milligrams over here in my no column. And I'm going to put X over my milliliters because I don't know how many milliliters at this point. Does that make sense? And then how do I solve this problem? Just cross multiply. Okay. So 2 times X is what? 2X. 1 times 20 is 20. How do I get X all by itself? Divide, right? I divide by 2. If I do that, X is going to fall out by itself. But what do I have to do if I divide one side by 2? I've got to divide the other side by 2, and what does that give me? X equals 10 milliliters. So is everybody okay so far? Like I said, I know some of you probably got this real easily, but I just kind of want to walk through the steps anyway, just to make sure everybody's on the same page. Okay, so we've figured that part of the problem out. Now I need to figure out how much etomidate I'm going to give anyway. So I have a 175-pound patient, but I need to give my dose in milligrams per kilogram. So what am I going to have to do with pounds? I'm going to have to convert that to kilograms. What is the conversion factor? 2.2, right? 2.2 is definitely a number you're going to want to know. That'll come back to haunt you time and time and time again. In this program, the tests, and even when you take national registries. So I just divide 175 by 2.2, and what does that give me?
79.54.
So 79.5 kilograms. Everybody's okay with that? So then to find the dose, I just multiply 79.5 times 0.3. Is everybody okay with that so far? So 79.5 multiplied by 0.3. What does that give me?
23.9.
Okay. 23.9 and some change. How about we just round up to 24? Is everybody okay with that? Okay. So we want to give 24 milligrams of etomidate to our patient. Okay. So we go back to the question here. How many milliliters will you have to draw up? So this is where we can set up that dimensional analysis again. What do I know for a fact?
You have 2 milligrams per ml.
There we go. I know that I have 2 milligrams in 1 milliliter. I'm going to set that equal to 24 milligrams. That's what I want to give, right? So 24 milligrams, and I want to give X milliliters. Okay, what's 2 times X? 2X equals 24. All right, how do I solve for X? 24 divided by 2, right? What is that? That's 12 milliliters. All right, so that's how many milliliters I'm going to need to pull. So how many vials am I going to need? I'm going to need 2 vials, right? Because I only have 10 milliliters in a vial. So I need to pull a full 10 milliliters, and then I'm going to need to pull an additional 2 milliliters out of my second vial. Is everybody okay there? Is that one? All right. All right. Excellent. All right, so we'll just move on down to question 2. Let me erase this here. Okay, so question 2. So now the patient has been induced, and you're going to pull up succinylcholine. And the dose of a succinylcholine is 1.5 milligrams per kilogram. 0.5 milligrams per kilogram. All right. It's the same 175-pound patient, so we just use the same, 74 or 75?
79.
Or 79.
I used 80.
Yeah, we use 80. Whatever works. All right. How many milligrams are required? How many milliliters did you put in the syringe? Well, let's figure out how many milligrams we need to pull, because that's easy, right? What do we do?
Times 80.
Okay, yeah, so 80 multiplied by 1.5, what does that give me? 120? Everybody more or less got there? You know, within a few milligrams, of course. So yeah, 120 milligrams. So that's the total dose I need to give, but I need to figure out how many milliliters I need to pull now. So if I look at the vial, it is a 20 milligram per milliliter vial, and there's a total of 200 milligrams in, let's see here, 10 milliliters. All right. So, what do I know for a fact? What do I know for a fact? It says right on the vial, on that picture there, it says I have what? 20 milligrams per milliliter. Everybody's okay there? I don't need to do any math to figure that out. I just look at the drug, and you should be anyway, right? You remember the 6 rights of administration. You don't look at it anyway. So I know for a fact, so I'm going to put no here. I know for a fact that I have 20 milligrams per 1 ml. And what do I want to know? Well, I'm going to give 120 milligrams, right? Everybody agrees? That's more or less what we're going to give 120 milligrams. And I want to know X milliliters. I want to know how many milliliters I need to give. Okay, same thing. Cross multiply this. 20x equals 1 times 120 is 120. Divide both sides by 20. That'll give us a nice even number there. And what's 120 divided by 20? 6. X equals 6 milliliters. So I'm going to have, how many vials of succinylcholine will I need for this patient?
You're just going to need the 1.
Just the 1, because that 1 vial has a total of 200 milligrams in 10 milliliters. So I'll just pull 6 milliliters out of that 10 milliliter vial, and away we go. Everybody okay there? All right. So now it's talking that we've done the intubation, and we're going to give a long-acting paralytic, the Vecuronium. We're going to use that 80 kilogram patient. Everybody's okay there with the weight. And we want to give 0.01 milligrams per kilogram. 0.01 milligrams per kilogram. And I have a vial of Vecuronium that has a total of 10 milligrams. And I believe that I just gave you this. It's 10 milligrams and 10 milliliters. What does that reduce to? 1 milligram per milliliter. Awesome. Okay, so what is 80 times 0.01? What is that? 0.8. I've just moved my decimal point back a couple places. So 0.8 milligrams. So I need to administer 0.8 milligrams. Everybody's okay there? So what do I know for a fact? Going back to the dimensional analysis, what do I know for a fact? I have 1 milligram in 1 milliliter. What do I want to know? There we go. I want to give 0.8 milligrams, and then I'm going to make X, milliliters X again. Okay, 1 times X is just X, right? Equals, what's 1 times 0.8? 0.8 milliliters. And that should make sense because my concentration is a 1-to-1, right? It's 1 milligram and 1 milliliter, so 0.8 milligrams should equal 0.8 milliliters, right? By having 1-to-1 concentration. All right, that's handy. Okay, now we kind of up the ante a little bit when we get into those pesky infusions. Okay, so I'm going to be initiating a nitroglycerin drip. Patient has STEMI. That's too bad. You're going to use microdrip tubing. What is microdrip tubing? Good. So 60 drops per milliliter. And you want to start your drip at 15 micrograms per minute. So reasonable. Patient weighs 180 pounds. 180 pounds. Okay, so how many milliliters per hour? So this is asking a couple things. One, it's asking how many milliliters per hour. And two, how many drops per minute. Well, what's the beauty of using 60 drop tubing? What's the beauty of that?
The milliliters per hour equal drops.
Yeah, milliliters per hour equals drops per minute when using 60 drop tubing. That's the beauty of it. So there isn't a whole lot of ambiguity there. Okay, so what do we have here? Well, let's look at our nitro. We have a bottle that has 250 milliliters and I have a total of 25 milligrams. So I have 25 milligrams of nitroglycerin in 250 milliliters. You guys okay with that? Can we reduce that down a little bit though? Yeah, I can divide 25 into 250, right? 25 divides into itself one time, and then how many times is 25 going to 250? 10. So that's 1 milligram in 10 milliliters. Is that good enough though? Is that good enough?
No, you want a 1 milliliter.
Right. What I need to do is, I need to reduce this as far as possible, and if I'm giving a dose in micrograms, everyone see that we're giving a dose in micrograms? My dose is in micrograms, my concentration needs to be in micrograms. If my dose is in milligrams, my concentration needs to be in milligrams, grams, milliequivalents, whatever. So I need to reduce this down even more. And how many micrograms are there in 1 milligram? 1,000, right? 1,000 micrograms. So 1,000 micrograms in 10 milliliters. Everybody's okay so far? 1,000 micrograms is the same as 1 milligram. And now can I finally reduce this down to 1 milliliter? Yeah, I just knock out a 0. These zeros cancel. And that gives me 100 micrograms per 1 ml. Everybody's okay there? Okay, let's go back up to this weight. Where does this weight come into play in this problem? Nowhere, right? It's just thrown in there to throw you off. This is not a weight-based infusion. Okay, so there are a couple of ways I can get to the answer. We can use our non-weight-based formula here, right? Do you guys agree we can use that? There are a couple other things we can do. Let's look at this. So I need to give 15 micrograms per minute. Would you guys agree? If I need to calculate milliliters per hour, just think about this. I'm giving 15 micrograms per minute. How many micrograms is that going to be per hour? Okay, I can multiply 15 by 60, right? You guys agree? I can multiply 15 by 60. So what is that? What is 60 times 15? What's that? 5 times 0, 900. Right? So that's 900 micrograms per hour. Would you guys agree? All right. So I know for a fact that I have 100 micrograms in 1 milliliter, right? So I know I have 100 micrograms in 1 ml, and I want to give what? 900 micrograms? X milliliters? Hopefully the answer should be pretty obvious. That's going to be what? 9 milliliters per hour. And what do we say milliliters per hour always equals? With 60 drop tubing? 60 drops per minute. Did everyone get an answer close to that? More or less? All right, cool. All right. Erase this stuff here. And we're going to look at Diltiazem, or Cardizem. Okay, so we've got a 200-pound male. 200 pounds. All right. We want to mix 20 milligrams in a 150 milliliter bag and deliver it at a rate of 5 milligrams per hour. Okay, so what have I done? I have mixed 20 milligrams in 150 milliliters. Everybody's okay with that? Everybody's okay there? Now, I told you yesterday that what might a better way to be if you're going to mix Diltiazem? Is there a better, possibly better way of mixing it? To make the math really easy? Could you just do a 1-to-1, 100 milligrams and 100 milliliters, or something along the lines of that? Give yourself a 1-to-1 mixture. And that gives you a milligram per milliliter. That makes the math really easy, doesn't it? Because if you did that, then it would just be 5 milliliters per hour. But they forced us to do something different. That's all right. Okay, so we mix 20 milligrams into 150 milliliters, and we want to administer 5 milligrams per hour. So what's the weight? Where does the weight come in here? What do you think? It doesn't at this point. Yeah, it doesn't at this point. Okay, so let's look at this. I want to administer 5 milligrams per hour. Let's go ahead and reduce our concentration. 20 milligrams and 150 milliliters. Okay. Do I necessarily have to reduce it for this problem? I don't have to because I'm using milligrams. Okay. So that's what I know. And what do I want to know? Well, I want to know this here, right? 5 milligrams. 5 milligrams equals X milliliters. So 20X equals, cross multiply, what's 150 times 5? 0. What's 5 times 5? 25. 1 times 5 is 5. 7. All right. Equals 750. I can divide both sides by 20 here. 75 divided by 2. 2 2 goes into 7 how many times? 3. That's 6. That's 15. 2 goes into 15 how many times? Well, it doesn't. Only 7, right? So that's 7. That's 14. That gives me 10. I need to add a decimal there. 2 goes into 10 how many times? 5. 37.5. We can't really deal in half a drops, can we? So what's the general rule of rounding? If it's 5 and above, we round up. So let's make that 38 milliliters. So if I give 38 milliliters per hour, that will equal 5 milligrams per hour. Would you guys agree? Because there are 5 milligrams in 38 milliliters. And what's the dose that they ordered? 5 milligrams per hour? Is everybody's okay there?
So even though Diltiazem, like my guide here, it says it is a weight-based
It is.
kilogram. So why didn't it factor in here?
They just gave you the dose. They said, this is what we're going to do. Basically, they gave you a situation where they said, don't think about it, just this is the number that we want you to work with. Yeah. Okay. So what we've already done at this point is they're assuming you've already given the bolus. You've given your bolus of Diltiazem, and now you're starting your maintenance infusion. And is 5 milligrams per hour a reasonable starting point for a Diltiazem drip? You guys remember covering that? Yes, that's a reasonable dose to start at for Diltiazem, at 5 milligrams per hour. Okay, we got that out of the way. All right, some good old lidocaine. So remember, there are kind of 2 flavors of lidocaine we run into, the 100 milligrams in 10 milliliters and the 100 milligrams in 5 milliliters, and this just happens to be the 100 milligram in 5 milliliters. Okay, so got a guy in VFib, or gal, we don't know. You give epinephrine, blah blah. You need to administer 1.5 milligrams per kilogram of lidocaine. Is that a reasonable dose?
Yes.
Okay, I don't know. I need to see some heads shake north and south or east and west to tell me.
Yes.
Okay, yeah, north and south, right? 1.5 milligrams per kilogram is a cardiac arrest dose for xylocaine, or lidocaine rather. Okay, we've got a patient who weighs 270 pounds. All right, that's Shane's little brother. Because Shane's a little south of, or north, I guess, a little north of 270, but that's all right. I won't hold it against him. So 1.5 milligrams per kilogram, 270 pound patient, and we have lidocaine that's 100 milligrams in 5 milliliters, and of course that reduces to 20 milligrams in 1 milliliter. Everybody's okay there? All right, so let's figure this out here. First of all, we need to convert pounds to kilograms, right? Because this is a weight-based bolus. So let's do that. Pounds to kilograms. So what's 220 divided by 2.2?
122.72.
123, how about that? You guys okay with that? 123 kilograms. All right. So now all I do is multiply this by 1.5, right? 123 multiplied by 1.5, what does that give me? 184, 185? You guys go with that? So we need to give 185 milligrams of lidocaine. That should be fairly easy to do, right? Because we know what we've got. We know that, I'll write the note here, we know that there are 20 milligrams in 1 milliliter. And I want to know 185 milligrams, and then that's X milliliters. 20 times X is what? 20X equals 185. What's 185 divided by 20?
9.25.
Say again?
9.25.
9.25 milliliters. So how many syringes of xylocaine or lidocaine am I going to need?
We need to.
We need 2, right? Because there are 5 milliliters per, so 2 of them will be 10. So I need to draw up an entire 5 milliliters, or administer an entire 5 milliliters, and that will leave me with how many more milliliters to administer? 4.25 milliliters from the second syringe of lidocaine. You guys okay there? All right. So now we're gonna follow that up with a lidocaine drip. A lidocaine drip. All right. So we want to start our lidocaine drip at 3 milligrams per minute. Is that an acceptable dose for a lidocaine infusion? What's the dose? What is the range for a lidocaine drip? 1 to 4 milligrams per minute. Yeah, so that's fine. Okay, how many milliliters per hour? How many drops per minute? Well, we're going to use 60 drop tubing, right? So that makes it simple. All right, so what do we have here? I have lidocaine, I have a bag of it. 2 grams. 2 grams in 500 milliliters. Well, that's not convenient because we need to drop this to milligrams, right? My dose is in milligrams, I need to have my concentration in milligrams. Does that make sense? Okay, so let's go ahead and reduce this down. 2 grams is how many milligrams? 2,000 milligrams in 500 milliliters. 500 milliliters goes into 2,000 how many times? 4. So I have a 4 milligrams per 1 ml. Are you guys okay with that? 4 milligrams per milliliter. Okay, fair enough. So, if I'm giving 3 milligrams per minute, think about this, 3 milligrams per minute, how many milligrams per hour am I going to need to give? 180, right? So, I need to give 180 milligrams per hour. So how about we go down here to what do I know for a fact? What do I know? There we go. I know I have 4 milligrams in 1 ml. And that's going to, and then what do I want to know? Well, I want to know this 180 here, right? So 180 milligrams x milliliters. What's 4 times x? 4x. 1 times 180 is 180. What's 180 divided by 4? Say it again. 45? 45 milliliters per hour. Now, is there a super fast shortcut I can use if I have lidocaine that is a standard concentration? The standard concentration of lidocaine is 4 milligrams per milliliter. That's a standard concentration. Is there a shortcut? The lidocaine clock, right? You guys remember that? The lidocaine clock? So just draw a circle here, all right? I'm going to do 4 here, a 1, 2, 3, like that. I'm going to put 15 here, 30 here, 45 here, 60 here. And I want to give 3 milligrams per minute, so I'm going to go over to 3 and draw a circle, and that gives me 45 milliliters per hour. Do they match? They do. So we should be pretty confident at this point that that's the proper dose. All right. You guys doing good so far? That's pretty quiet. Some silence there. Okay, so we're going to give furosemide. Patient, you decide to give the patient furosemide at a dose that is twice that of his daily dose. Okay, he normally takes 40 milligrams q day. So how much do we want to give him? Okay, so we're gonna give him 80 milligrams. All right, and it asks us how many milliliters. We've got a vial, a 10 milliliter vial, and it has a concentration of 10 milligrams in 1 milliliter. Well, this should be pretty easy, huh? Okay, because that's what I know. Well, I want to know, well, I want to give 80 milligrams. X. What's 10 times X? 10X. 80 times 1 is 80. Okay, X is going to equal 8. There we go, 8 milliliters. All right, that's an easy one there. Easy, easy. All right, 9. All right, so we got somebody, possible hip fracture. We want to give 75 micrograms of fentanyl. Is that reasonable?
Mhm.
Yeah, that's reasonable. Okay, and then I have a Carpoject that has 100 micrograms. 100 micrograms in 2 milliliters. So that gives me 50 mcg per milliliter. Do you guys agree? I know that. That's what I know. Is 50 per milliliter. I want to know 75 here, right? Everyone's following me okay? All right. I want to know 75 X. All right. So 75, that's just 75 equals X. All right. Divided by 50. 50, 75 divided by 50, what does that give me? What does that give me? We'll do it long. We'll do it long now. So 50 into 75. How many times does it go to 75? 1 time. That's 50. Okay, 5 and 7 is 2. 0 and 5 is 5. Now, what I can do is I can add a 0 to the end of that, right? But if I add a 0 and make that 250, what do I have to do up top? I have to add a point there, right? And then 50 goes into 250 how many times? 5, so 1.5 milliliters. If I drop 1.5 milliliters of the 2 milliliters that I have, that'll give me 75 milligrams. Okay, your patient is not tolerating the situation very well. Gonna give some Midazolam. Okay. You decide to give 2 milligrams. So what do we have here? I've got 5 milligrams in 5 milliliters. Well, what is that? That's just 1 milligram in 1 milliliter. And if I need to give 2 milligrams, how many milliliters is that going to be? 2 milliliters. Ridiculously simple. That's all right. You need a problem like that every so often, right? Something that's ridiculously simple. Let's see here. Oh no, it's never easy, is it? So now it looks like the patient's having an allergic reaction. So we're going to administer diphenhydramine at a dose of 26. Really? Okay. Let's just do it because we're just going to do it for the math to make sure we're good with the math. You just give 25 or 50, right? That's in real life. But this is the hospital of unreality that we're working in, all right? All right, so we have a vial of diphenhydramine. That's 50 milligrams per 1 ml. Everybody's okay with that? So I want to give 26 milligrams in X. 50X equals 1 times 26, 26. What's 26 divided by 50? 0.52. All right. Milliliters. You pull your 0.52 milliliters and give it, right? All right, let's see, moving right on down. So the same patient's really having problems, and you think it's because you gave the Midazolam to them. You want to reverse the Midazolam, so we're going to use Romazicon. I'm not saying we'd actually do this in reality. And again, this is a hospital of unreality, so just kind of roll with it. Okay, so I want to administer 0.2 milliliters, 0.2 milligrams rather. And I've got a vial that is 0.1 milligrams per milliliter. All right. Is this a ridiculously simple question or what? Everybody got this? Okay. I'm going to administer 0.2 milligrams, and I know 0.1 milligrams per milliliter. How many milliliters do I need to pull out of that vial? 2. Oh, man. Genius. You're genius. All right. Yeah. Uh-oh. 14. The dreaded dopamine calculation, right? Dreaded dopamine curve. Oh, 13. Narcan. Okay. So now you think, well, maybe it was the fentanyl that caused the problem after all. So, boy, we're just going to make this patient a pharmacy, right? You're going to draw blood from them. Administer their blood to people because it has every drug known. You decide to administer 0.4 milligrams. What's the concentration?
0.4 milligrams per ml.
Any questions on how to find that one out? Okay, you guys got this. All right. Now you're working on a patient in cardiogenic shock. Yeah. We've been talking about that this week, haven't we? No, we haven't. We've got some brain draining going on, don't we?
It's Thursday.
Oh, you know, when I was in the military, they used to call us soup sandwiches. We're like that, so we've got some soup sandwiches today. Yeah, I don't know why. I'm sure there's some historical pejorative connotation there, but I don't know what it is. Okay, so what do we want to do? 5 mics per kilogram per minute. Oh, that's not a very big dose. That's all right. Okay, so that's what we want to administer. Of course, our patient can't be in kilograms, has to be in pounds, right? Just think, if we ever got to go totally metric in this country, we'd never have to worry about that conversion again. Wouldn't that be nice?
Be awesome.
Everything would be in kilograms. Okay? Any of you guys have kids? Oh, just one? Okay, because none of the people, yes, none of the people in this room are going to be able to change the country. So we're going to have to leave it to your kids. Okay, so if you have kids, you know, maybe in the next 20 or 30 years that can be a major policy change, right? You can go to the metric system. Make dosage calculations easier, right? And we could buy our gasoline in liters. No. This is the United States you're talking about. All right.
It would go up because of all the metric code.
Yeah.
It just happened here before.
Yeah. All right. So let's just convert pounds to kilograms real quick.
65.5.
66. Are you guys good with that? 66 kilograms. I'm good with that. All right. So what do we have here? We have 400 milligrams of dopamine in 250 milliliters. Okay. 400 milligrams in 250 milliliters. I need to give my dose in micrograms though, right? So can I have this concentration? No, I need to convert that to
0.4 per 250.
Okay, yeah, so 250 goes into, so 250 goes into 400 how many times? You can do that. Or, let's just do this. 400 milligrams is how many micrograms?
0.4.
Micrograms.
So, 4,000. 40.
40, 400? Okay,
400,000.
what's 1,000 micrograms equals 1 milligram, right? So 10 milligrams would be 10,000, 100 milligrams would be 100,000, 400 milligrams would be 400,000. Okay, so 400,000 micrograms in 250 milliliters. Can I knock that down a little bit? Can knock a zero out. What's 25 into 40,000? So 25 goes into 40,000. 1,600. Yeah, it's on the back too. But I was just going through it. So our ultimate concentration, if you were really observant and you looked at the bag and the big white letters on the red label and 1,600 micrograms per milliliter, that could have said, well, we can still do it here, but 1,600 micrograms per milliliter is our concentration. Okay, we're going to give 5 mics per kilogram per minute. So let's figure out what our dose is. What's 66 times 5? 330, right? 330. So now what we can do is we can go over and we have our weight-based formula here. And let's just plug and chug, right? Just plug and chug. So what's the dose?
5 micrograms.
Okay. What's the weight? 60 what? 66. Okay. What's the drop factor we're going to use?
60.
Yeah, we're always going to use 60. And what's our concentration? 1,600. All right. So what's 5 multiplied by 66 multiplied by 60? Well, what's 66 multiplied by 60?
The total's 19,000.
39,600.
Okay, and then times 5 is going to be what? 20,000?
19,800.
19,800 divided by 1,600.
12.37.
So 12, right? So 12 drops per minute or milliliters per hour, right? Because we're using 60 drop tubing. All right. Is there a super quick way of getting a close ballpark measure if we're using a standard concentration of dopamine? The clock, right? And it only works for the 1,600 mics per milliliter. It has to be standard concentration. All right, so let's do our dopamine clock here. You guys remember how to do that? So 15, 30, 45, 60. All right. What numbers go here?
1,600.
So 400 goes by the 15, right? 800 by 30. 1,200 by 45. 1,600 here. All right, everybody's okay there? And we came up with 330, right? You guys agree? 330? So, 330. 66 times 5, right?
Right.
330 mics per minute. Okay. So right about in here. Did you guys agree? Right in there, more or less. So it's going to be less than the 400. It's going to be less than 400. So guesstimating 13 or so. And what did we get for our answer? 12. Are they pretty close? Pretty close, aren't they? So the dopamine clock pretty much matches what we calculated. Everybody's good with that? Let's go ahead and take a little lunch break, guys. Take some lunch, clear our minds, and we will go ahead and we have, what, 5 more to go? We'll do those after lunch. How does that sound? All right, take a lunch, get out of here.
What time?
1 o'clock.